Hello, and welcome to Boot Camp Unit 8A, Algebraic Expressions. We are now going to try to quantify situations in terms of letters. It need not always be the case if we have a specific situation, though it at least gives us somewhere to start. So when we write algebraic expressions, we want to think about what operations we're doing. Looking at the table here for a second, if we say 11 more than x, I'm taking a number and I want 11 more. For example, in a concrete case, if I had let's say I have 3 trees and I want 11 more, how many would I have? I would have 14. Why is that? It's 3 plus 11. There's nothing special about 3 and 11. The 11 was given to you in the problem, but the 3, there is nothing special about it. We're going to use a variable to represent that 3 then. So if we say 11 more than x, we're saying x plus 11. That x, once again, being a stand-in for any number that you want. We can also have 11 less than x. This is a cue for subtraction. And we can say x minus 11. In the same vein, for a concrete example, let's say I have 14 trees. And I have way too many. I want to get rid of 11 of them. If I take the 14, subtract 11, I'll get the 3 that we have, or I should say that we want. There's nothing special about that 14. I could pick 15, 16, 17, or as many as I wanted. But the key is that the formula that you're using is still the same, x minus 11. There are other keywords that you'll see for algebraic expressions, though it often is very context dependent. So for subtraction, for example, you'll typically see less than subtracted by. For addition, you'll see things like the word sum or put together or in total. So it really all depends on your situation and how you interpret what you're given. We then have multiplication and division. 3 times x or 3 times x. Or shall we say, the product of 3 and x, another keyword for you. In a concrete case, let's say we had 4 and we want, so we did one house of trees and they wanted 3, and we're gonna do the same for a couple of our neighbors. How many will we have in total? Well, we'll have 3 times the 4, or 12. 3 times x. In the same vein, we have the quotient of x and 4. We have x divided by 4. It is worth noting that much like when you're doing subtraction and division normally, that order does indeed matter here very, very importantly. The quotient of x and 4 is much different from the quotient of 4 and x. In the latter case, we have 4 over x compared to x over 4. Those are completely different. We can also put these together. If you start putting them together, however, do once again note that order is important. On the right, you'll see 2 examples in black. The top is 11 more than x and then multiplied by 3, or 3 times the sum of x and 11 in full words. On bottom, we have 3 times x plus 11 in full words. 11 more than 3 times x. Notice how I'm phrasing these a little bit differently. 3 times the sum of x and 11 more than 3 times x. The ordering of your words, your phrasing, is very, very important with expressions. How you deal with those will depend on what application you're looking for and how far ahead you are in boot camp or not. We then have algebraic equations. If expressions are just kind of expressing a situation, equations actually are putting it to use. Equations have equal signs. Expressions do not. And we'll get into this a bit more later. But when we have, for example, x plus 2 equals 4, to give you a little sneak peek, you can either try to intuitively figure out what x is, in this case 2. 2 plus 2 equals 4. Or we can do, as the term is going to be, isolate x and solve for x. In this case, by doing PEMDAS in reverse, subtracting 2 and getting x equaling 2. On the bottom, we have 3x equals 9. We can again try to intuitively figure out that x is 3, because 3 times 3 is 9, or later on, dividing by 3 to get x equaling 3. It is worth noting that we call these one step because they are just one algebraic move away from being solved. We then kind of want to look at this in these concrete cases. This is constructing numeric expressions. The important note to make here, once again, is that order is crucially important. We will follow PEMDAS. 2 plus 3 is 5. 5 times 5 is 25. Minus 1 is 4. Making sure we go in PEMDAS order. That was Unit 8A, an Introduction to Algebraic Expressions.